That's correct.
Yes, that's it. Yeah, okay. For some reason, I was thinking.
And then if you look back here, there's two of them that are the same, but they're releasing that activity.
So there's 5 releasing and 2 inhibiting.
Are the growth hormones.
Sorry. Oh, on your pituitary. Yeah.
Whatever.
Yep. That makes sense. Yep. That makes sense.
So you're at least, no, you always have 2 of them on the other side.
Releasing. Those ones have R's.
Yeah.
The other ones have I's.
Yeah.
If they're spelled out, GHRH, it's gonna be the huge long word, and I'm gonna be like.
Well, then I'm just gonna do the first letter of each one.
Oh, and I should tell you for the quiz and exams, always use the full name and the abbreviation. I'll have both of them on there, so you can, if it's easier for you to remember the abbreviations or the whole words.
Okay.
I don't know. I think the whole words is easier because it kind of tells you what it does,
Yeah.
rather than just memorizing a series of letters.
I know. This looks like hieroglyphics right now.
That's just a page number on mine, because I don't want to write it on my screen.
All right. Anything else? All right, let's take our quiz then. I guess after our quiz, do you want to join their group over there? With Edith. Did I give you all enough back? There's some more. All right, pass those on up if you didn't already. Here are these.
I tell you what doesn't work. No, we got a brain.
That person's not going to make it because their brain's not up. That's because my 201 students didn't put it back together, and I don't know how to put it back together. It's missing all the inside parts. All right, so what type of gland secretes hormones into the fluid and into the blood? That is endocrine. Where do exocrine glands, where do they secrete to? Like into the ducts and outside the body, basically. What are the two chemical classes? Exocrine and endocrine, protein and lipid, lipid soluble and water soluble. That's right, lipid and water. Which of these is not a releasing hormone produced by the hypothalamus? Growth hormone releasing, thyrotropin releasing, no, gonadotropin releasing, or luteinizing releasing? It's the last one. There's no such hormone as luteinizing releasing hormone. I made it up. What is it called when two hormones acting together cause a greater response? So synergistic. And what hormone produced by the pituitary causes milk production? It's prolactin. Lactation, lactose. You know that prefix. What in the world? All right, so let's do some basics first. Maybe I should ask you, what do you know about hormones?
How they work in the male and female body.
You did learn about the male and female body, definitely. What is a hormone exactly? You're like defining it.
Molecule released in one part of the body that regulates activity of a cell in another part of the body.
That's a good definition. So, did y'all hear that? You want to say it louder? You can do it.
Molecules released in one part of the body but regulates activity of cells in other parts of the body.
Okay, and how do they get around? Right, so just travel through the blood. All right, so in order for those cells to respond to the hormones, like the correct ones, they have to have the right receptor. So in biology, everything's all about shape, as you probably saw with enzymes back in 201. And the receptors can be out on the cell membrane and bind to the hormone there, or they can be in the organelles, in the cytoplasm, or even in the nucleus itself. Because as you'll see in a minute, there's some hormones that just go straight through the cell membrane and look for their receptor inside every day. Every day they knock something into that hole. And we'll talk more about that in a little bit. And it is very specific. So one hormone has one receptor that complements it, as a shape that it fits into. I don't know why I have these animations. Makes me mad. All right, so the two classes, they travel differently through the blood. Water soluble, they just go into the blood's full of water, travel through. Uncomplicated, pretty simple. But things like your steroids, so estrogen, testosterone, progesterone, they can't just go in the blood because they're like oil. Put them in the blood and they wouldn't go anywhere. So instead they have to have special transport proteins that they bind to. And the transport proteins, like water, and it'll take the hormones around. All right, so how do the water-soluble ones work? If they're water-soluble, is it easier for them to go through a cell membrane or not? Because remember, if you're lipid-soluble, you can go through a membrane. If you're water-soluble, you're polar, or you're charged or something. So if they're going to activate a cell, they have to bind to a receptor on the surface, like this purple receptor. So here's the hormone coming through, binds the receptor, and then the receptor is going to activate things inside the cell. And those molecules that the receptor activates are usually called second messengers. So like, the hormone's the first messenger, turns on the receptor, and then the receptor turns on some other protein inside, and second messenger. What does it tell the cell to do? Activate transcription, or make more of a protein, or turn on or turn off enzymes. So since we just did a reproductive system, what did LH do in the male, for example? Where's LH made? So it made the pituitary, goes down to the testes, and what is it? Oh, and it tells the cells down there to transcribe more testosterone or turn on enzymes that make testosterone in that cell. All right, what about the lipid-soluble ones? That's the one in this blue triangle. It came in the blood with a carrier protein, and it can go straight through the membrane all the way into the nucleus. So its receptor is kind of floating around in the nucleus there. Let's go to the nucleus, bind the receptor. Same response though. Make more or less of a certain protein, or turn enzymes on or off based on how you need to fix the problem. All right.
Is there?
What in the world? Is it the right thing? Oh, clicked on the wrong one.
No, I didn't.
Come on. Let's see, I mean, plug it. All right. Ooh, that's a mean one. Yeah, unless.
Our bookstore bottom back.
Yeah.
The ones that you had to buy, but we had to they're pretty expensive.
Yeah, I mean, unless you're going to use it in all your classes, it's kind of.
It'd be for one class. Which I mean, if you use it or.
All right. So chat with your group there. I'll tell you it's not F. So you better reevaluate there.
Okay, so you gotta.
It can't be because for DA, the hormones and emotions.
They can't. Because there's no way to bind. So I think that's what I said. That's what I did too. Okay.
All right, final votes then. All right, so everybody changed to E, which is the right answer. So for A, every cell of the body is a receptor for every hormone. That would be a disaster.
Every semester.
Because, like, for example, luteinizing hormone, it's supposed to tell the testes and the ovaries to do something. It's not supposed to tell your muscles or your liver or your ovary, yes, your uterus or anywhere else in the body to do anything. So only the places that respond have the receptor that matches it. And for D, they don't have the same shape because the hormone's like the key, the receptor's like the lock. So that'd be like you going to your door and trying to open your doorknob with another doorknob, which is kind of a fun image, like just banging your doorknob on there to another doorknob and trying, I don't know.
Oh, goodness.
So lock and a key. All right, how do cells respond to activation by hormone? All right, so I'll tell you it is E, so you can talk to your group then and decide which of those it is.
I was thinking whether it was. That's what I'm saying. It's either A and C or B and D together. But I don't know which one. So what? C and D. Turn on and off and end off. Okay.
Because I feel like that's what you said, like, how we see it.
Okay. Okay.
I really don't want to talk to people about that.
I was like, I don't know. It's either. I knew these shirts.
Well, it just depends on what it means.
I don't have the PowerPoint today, so
Yeah. Because it's not
Matt,
that
right. Yep. Good job.
All right, so what do y'all think?
C and D.
Give me some more.
I guess
It's all of them.
I was like, maybe.
It is all of them.
You're still right.
So sometimes a cell needs to make more of something. Or, for example, what about those inhibiting hormones that you were just looking at? What do you think they tell the cell to do?
Big less.
Make less, turn off enzymes. So there's always, could be either way. Or maybe it's telling the cell to turn on some enzymes and turn off some enzymes. So basically it could be anything. Trick question. I said both of these things not too long ago.
I know. But I was just thinking only two of them.
That's right.
Remember the conversation I had with my little sister this morning?
All right, so try question 1 on your own.
Yeah, there's 4
Oh,
here.
that's funny. I had 4 out, and then I'm like, there's only 3 people at this table. And then I took one of them away. That's so weird.
Thank you.
Sure. All right, draw yourself some shapes.
Yes.
You're not going to find any answers in your book. It's really,
That's what I was thinking. Like, if I'm just thinking that, I can make it. Like, that's kind of a rectangle. So maybe a complete square.
all right, so go ahead and check in with your group there, see what kind of pictures y'all got.
Because you could do a rectangle around it. Yeah, I was thinking.
And remember,
No, do like a little thingies with like Jason.
Oh, yeah, I was thinking 2 points. That works. Okay, that works.
it's a good picture.
But I'm lost on the other two.
Yeah, the circle.
Well, it's the same idea. Just has to fit into it, right? If you can do the first one, I'm sure you could do the other two. Yeah, see, y'all are doing it right. Just need to make that one more of a square, but that's like what would happen to me. Like, I'm trying to make a matching shape and it just doesn't come out right.
I keep on drawing the same my life.
Look at Annabelle's, look how pretty hers are. I'm gonna hire you as my board picture drawer.
I was like, we can't do another.
I'm like, and my assistant here is going to draw these hormones and receptors and kidneys. That'll be your job.
Can that be on the test?
No?
Well, how is that going to fit into that?
No,
just
you
like-
gotta do it backward, upside down. Flip it. Build a two triangles around it.
Yeah, I think you may be thinking of it in 3 dimensions. I don't know about the second one.
Yeah, I was like, I didn't know what it is.
I think you need to put some stuff on the outside of it so it like fits into it like a puzzle.
How she did.
Yeah.
Yeah,
We can do this like that.
right? Does that make sense?
Yeah.
All right, so y'all gotta.
I was making it way more complicated.
Like an 18 free.
Right?
We were thinking that like all
So yeah, it's just basically like a puzzle piece. So the hormone has a shape, it fits into the receptor, which is a shape that it'll fit into. That's how it knows which one to bind to. All right. Any questions so far? Oh yeah. Question 2. All right. So the hypothalamus is the boss of the endocrine system. It's kind of, so the hypothalamus kind of starts everything. It kind of makes sense. It's way up there in the brain. You probably, maybe you saw it when we dissected the sheep brain. It's like right in the middle. And hanging down off of it is the pituitary. And the hypothalamus, its basic job is to tell the pituitary what to do. So I think of it as like the boss, and it's a very like standoffish boss that doesn't talk to his employees. He just has like this hated like assistant that goes around and does everything. That's the anterior pituitary. All right. Come on. Come on. Keep going. It's frozen.
too many graphics.
I know. I always forget this is the one PowerPoint that they got put in there, and I hate them. I always forget until I start using it. All right, so anterior pituitary, is that in the front or the back? Right? So this is the front, a little bit of the front. This is a little bit behind it, so it's the anterior, posterior. We're going to talk about the anterior first. And it's hanging down from the hypothalamus by the infundibulum. I hate that word, I can't say it. Infundibulum. I don't know. All right.
Oh my God, you and I.
So we're going to talk more about these in a second, but there's like a special blood vessel connection between the hypothalamus and the anterior pituitary, which you'll see. Are you seeing similarities to a previous chapter? Is that the problem?
Killing me. Stop. I feel like I'm in church. And I'm not supposed to laugh.
I don't see it. I
It's
just-
not the same person, but you laugh.
Oh my goodness. All right. So anyways,
Okay, 18.3. Oh, right.
all right, here's your crazy table. So as we were looking at it, the hypothalamus, basically it senses what's going on in the blood or takes input from the brain to kind of decide what to do. And when it decides something needs to be done, it's going to make one of these releasing hormones or maybe some of these inhibiting hormones. They go to the pituitary and they tell the pituitary to make or not make these hormones. So for example, have you heard of like the women suddenly like lactating when they see like a crying baby, if they're already have a baby, not just randomly? That's because they see that stimulus of crying baby, brain receives it, tells the hypothalamus about it. Hypothalamus makes prolactin releasing hormone, which goes to the pituitary, which then makes prolactin. Starts to they go find a baby.
Go find your baby.
Or maybe, did we do this one already at some point? Maybe it's in patho. So your thyroid hormone warms you up, increases your metabolism. So if you get cold, hypothalamus can tell you're cold. It makes thyrotropin releasing hormone, which goes to the pituitary, and it tells the thyrotropes to make thyroid stimulating hormone, which is going to go to the thyroid. So for a lot of these, it's like a multiple step kind of process. Always starts with the hypothalamus. All right. And in order for those hypothalamic hormones, the releasing and the inhibiting hormones, to go to the pituitary, you need it to be rapid. You don't want to just put them in the blood and have them just circulate through the whole body. You've got the pituitary right there. So this is a special system, which is called the hypophyseal portal system, that takes the hypothalamic hormones straight to the pituitary. So you can get like a very rapid response that way. So it's a network of blood vessels. And we're going to look at a picture of it. So it's put into what's called the primary plexus, and that's arterioles, so like smaller arteries. And they go through capillaries, through the portal vein, to the anterior pituitary. You can see that right here. So you've got some arteries and capillaries up here in the hypothalamus. Release hormones right there into the blood, and it travels straight through the portal vein. And then in the pituitary, there's more capillaries because you want to spread out the hypothalamic hormones to the whole pituitary, and then it'll respond. So you've got the releasing and inhibiting hormones made up here, traveling down, then it tells the pituitary to make one of those hormones. Right. I think I have a question about that. All right, what about this one? Oops. You know, that was a lot to digest. We're starting with the hardest part of the chapter, I would say. All right, so go and talk to your group. It's not E. Did everybody vote again? Oh, I think most people changed. So D is the right answer. What's wrong with C? What are they released into? That's the hypothalamic hormones, or into the arterioles. It is capillaries. That's because capillaries give you more surface area, so you can get more hormones into the blood faster. All right. I think we'll come back to that in a little bit. I want to do that other question. Come back to all that. Before we get going too far, I want to get back to, this is so annoying. All right. So we're going to do number 2 with your group. You're going to draw it on the table. Or maybe in pairs is better since we've got groups that way. So you're going to draw a simple diagram. And basically, I would do something like this. So you get the hypothalamus. And then you've got the portal vein. And then down here, you've got the anterior. All right, so you're going to use that table as a guide and draw us a picture, kind of showing the relationship between all these. And this means activate. An arrow. This means inhibit. See what you can do with that. I think I spelled pituitary wrong. I better fix it. So that table has all the information you need. So you look at it in your book, look at that one. So think about what's made where. How's it going?
Good, how are you?
Good. What in the world? All right, so just start at the top of that table. Where is HGH made? Hypothalamus or pituitary? Mm-hmm. So maybe write HGH down there. Mm-hmm. Human growth hormone. One hormone at a time, right?
At a time.
Mm-hmm. Okay. And what tells HGH to get made? Hypothalamus makes the GHRH. So you can write GHRH up here. And then are you gonna put a arrow or a T from here to here?
An arrow
Uh-huh.
from here to here.
Right. And so maybe y'all can like use different colors for the other hormones, sorry.
For the other.
Yeah. And then is there a hormone that tells it not to make HGH? Uh-huh. Where's that one made? Mm-hmm.
Draw another arrow, but don't put an arrow, put a line.
Mm-hmm. And that means don't make it. So you just do the same thing for the rest of them. Maybe in different colors, or a few different colors. There should be extra ones. All right, how y'all doing? Whoa. Okay. No, it's right. But we want to connect these specific ones to specific hormones here.
Yeah, we're doing it. Okay, we'll just bring them down and then we'll connect them to the ones that.
Right. So like have a line coming from here to some certain hormone. And from
So we'll
here.
just draw a line like that.
Uh-huh. So I don't know if using different colors will help maybe, or
We'll use, when we connect the lines,
Connect to.
so
oh, keep it, sorry, I wouldn't put it down here.
No?
I would say like just draw a line from there,
yeah, just draw lines.
because otherwise you think it's made there, you know what I mean?
You said different. And then FSA.
Well, let's, okay.
We'll draw lines with the pink.
Okay.
Which one? Okay.
All right, how y'all doing?
Okay, you have to, I messed up at first. So we started with our GHRH, went down to our HGH,
Uh-huh.
which then came up to inhibiting.
now-
So once I finally
Oh.
figured it out.
Except it's actually, the GHIH inhibits down here. So it'd be a line and a T. I know, this is what everybody always thinks. It actually goes to the pituitary and tells the pituitary not to make that.
So it's in here?
So it'd be a T there.
Oh, right here?
Mhm.
Oh, but it's in the hypothalamus.
It's made in the hypothalamus, and it goes to the pituitary.
Okay, because.
And I know what you're thinking.
Okay,
You're thinking
okay.
it stops them making this.
Yes,
It doesn't. It stops the pituitary from making that.
HGH. Oh, okay. Oh my gosh, this is gonna be nice. Okay.
So ignore this guy. I need to hear some.
Just that little part up there. And then this one is just a line. It's just like
That
that.
makes sense, because that's why people like for the steroids and stuff, they give themselves the HGH.
Uh-huh.
Right.
Yeah, yeah.
It's inhibited. Okay.
Well, it's, what do you mean? It's inhibited
Oh,
normally?
this is not.
Certainly when you get older, like after you're not a kid, you have way more GHIH than GHRH. And so then, yeah, they'll just take HGH and get, faster recovery, bigger muscles.
Okay.
You could, in theory, I guess, take that. I haven't heard of anyone doing that, but
Oh, yeah. Huh.
maybe it's not available.
Okay.
Yeah, it's
TRH.
TRH.
It's up here. I should make this way bigger.
Alright, do we want to erase this?
TRH.
Good thing I do.
Sweet.
I have markers on mine.
So I think y'all got them all.
And then
How many
the
colors do we
MSH
need?
is inhibited by dopamine.
Yeah, I mean, maybe if you've got them lined up so nice like that, maybe you don't have to use different colors when you copy it down.
Mine's a mess.
I have.
Yeah, so I think for y'all, when you copy it down, I might do theirs. I think you have everything right, but if you go back to look at this, it's going to be like,
I
oh.
got colors.
Just follow the
Do you think you could tell what's going on that later?
If I follow the lines.
Yeah, if we just follow the line.
So for
But your lines need arrows and T's on them at the end.
okay, so that's fine.
No, the arrows go down here.
So for your GRH,
So then which one's the T?
it's gonna increase, and then your GHRI is gonna block it.
Mm-hmm.
And then for your THS, your blocking is coming from your GH, and your increase is coming from your P. So for the FSH,
Because you said this one decreased.
yeah, you have your,
Decrease and increase.
yeah, so for your FSH and your LH, it's both increased by your ganatropin HRH.
Gonadotropin releasing hormone.
Yes, and then your PRL is going to increase by your PRH and decrease by your
So
PIH.
anytime it decreases,
Each a negative, and then increase. Your
Yeah, so-
ACTH is going to increase.
I think y'all are getting it. And what I would do, if you come look at what Annabelle and Brianne did here, that's probably what I would copy down. Because it's nothing really, it's the same idea of what you have, it's just the way they have it, it's a little more obvious what's going on. I told them to come look at your nice pictures.
She can start decorating it.
Hold on.
Oh, right, yeah, you need the dopamine there. So basically what you have is just they lined up like which ones went together.
Because the RL is
It's really
pituitary, so
bad.
it'd be PRH.
Okay, what's our next one?
PRL down here.
Again? Okay.
And it makes MSH.
And
my
then
gosh, I'm running
PIH
out
will
of
be up
space
here
here.
because it will
MSH.
inhibit it.
And it inhibits by PAH.
PIH inhibits it? Oh my god, no wonder our brains are all jacked up. Look at that. Is that all? Okay. Okay, now we draw that on our paper. So note to self, really big.
Yeah, and do you want to glance at Annabelle and Brianne? See how they organize theirs? That's maybe how you want to write it down.
Ours looks like that too. That's really funny. Okay, I'm doing it that way. That's fine.
Oh, wow.
That makes more sense after doing that. Yeah, you were way smarter on that.
Yeah, from teaching this for a few years, I know that everyone looks at this table and no one has any idea what it means to start with.
We know now.
Yeah, I know. Well, and I think part of it is it's not very well, the labels aren't very good on there, right? Like, I almost think the hypothalamus should come first on the left side,
And do like a natural reading.
something like that. I think that would make more sense. Do you like this little star on the PRH? It says, thought to exist, but nature is uncertain. So they're like, we think it's there, but no one's ever found it or isolated it or anything. So what I was doing is like an arrow for activate and like a T for block.
Yeah.
Right?
So this one would be the activate right there.
Uh-huh.
And then this one would be the block.
Right. But it's
So how do we
but
know
it's specific to certain ones. So like the GHRH,
So it'd go down here and then it activate
HGH.
HGH.
Uh-huh.
So it'd be the arrow, right?
Yeah, from GRH, or wait, GHRH to
To
HGH.
There's no decrease.
All right, so is it coming out better?
Yeah. Well, 5 it total, but.
Who even knows what I'm doing?
Well, you're doing perfect. And we just kind of left off the last one. We didn't really talk about melanocyte.
I think I got all this.
It'll activate the. So whenever these come down here, it'd be with the T, right?
Mm-hmm.
Okay.
Yeah, and so like the HGH one, which one blocks HGH?
It'd be the GHIH.
Uh-huh.
So then I just draw an arrow and then draw the little.
The T to the HGH. Yep. What else we got? This stuff.
Sorry, that was my son's doctor's office calling. I had to.
It's okay.
So that increases. The one that decreases, the HGH, is your GHIH. Decreases. Your GHIH decreases your HGH. That's where I'm going.
So you feel like that looks different? Those shapes?
Yeah.
At the
I
end?
just see the plus, and I mean my name.
Oh, you're making it a plus.
Yeah,
I
and
see.
then my blockage, stupid eraser. Yeah.
Yeah, you
see
could do it
there's
that
the
way.
plus, see the plus, and then that's plus.
Yeah, that works, I suppose. All right, so we do have to keep going. You'll have to finish drawing all those arrows at some point, although I think you pretty much got it. But now you could make a pretty one. So I wanted to talk about the hormones of the pituitary and what they actually do. So we've got prolactin, TSH, etc. And 4 of them are what are called tropic hormones. And they're basically their job is to go to another gland and tell it to make hormones. Like the one you already learned about, luteinizing hormone. Remember, it went and told ovary and testes to make testosterone, estrogen, etc. All right. So FSH, it's made by pituitary. You already learned about it. It helps with ovulation, development of the egg, and with sperm. LH, you know about that one. TSH, you haven't learned about that one yet. It goes to the thyroid gland, and it tells the thyroid gland to make thyroid hormone. Then you've got ACTH. It goes to the adrenal glands, and it tells them to make corticosteroids. And one of the main corticosteroids is cortisol. Have you heard of cortisol before? Maybe. It's the stress hormone. It's a pretty good measure of how much stress you're under. And it's very easy to measure. You can measure it in saliva. So that's why they use it a lot for different studies. And then prolactin, milk synthesis. And it does some stuff in males. We don't really have to worry about that. And kind of interesting because are women making lots of milk before they have a baby? Right? So what stimulates that milk formation? Birth and like actually nursing, right? Because if you give birth and don't nurse at all, do you ever really make much milk?
How
You
can
could never.
some women start lactating before they even have a baby? Is it just some type of...
Yeah, and I think there could be a little bit, but it's certainly not like the amount that happens after you're already nursing.
Okay, I just heard of people saying that.
Yeah, and I think it's pretty cool how it's like sensitive to how much is being like eaten by the baby. Like it'll change how much, or if you have, you know, triplets or something, the body just makes extra. It's kind of interesting.
No, I didn't follow it.
All right, what else? HGH, in like children and kids, it promotes bone growth. Like it helps. Remember how you had those growth plates, the ends of your long bones? And they grow from there. It tells basically those cells there to divide faster, make more bones. The bones get longer. It also has a role in controlling blood sugar levels. And kind of a fun HGH fact. You know, it's been like abused a lot with like baseball, football. And in adults, some of your bones can keep growing if they get too much HGH. That's like the bones in your face and your head. So have you seen pictures of like Barry Bonds, Sosa, McGuire? Have you seen, does it look like their heads are enormous? Yeah. Compare it to them when they were like 25, they have like a normal size head. And they took all this HGH and all their bones in their head and face got bigger and bigger. And now they've got these like massive heads. And they're like, no, I wasn't abusing anything. And you're like, well, what happened to your head? You have another explanation for that. All right. What's the next? Oh, we did 2 and 3. Let's see. All right. So with your group, take a look at that diagram you made. And I want to know how it's possible the pituitary can make a whole bunch of TSH at the same time that it's not making any prolactin. So we're gonna need to be very specific for number 3. So number, what?
How do they have anything to do?
Well, I mean, the hypothalamus and the pituitary connected.
Or why does the lack of a leaf of prolactin sexually?
Well, I think the point is it doesn't.
Oh, okay, so we'll say like one that has nothing to do with the other.
So, like, how does the hypothalamus tell the pituitary to make thyroid hormone but not make prolactin?
By increasing the TRH, but not increasing
You're on the right track. So what are y'all saying for 3 there?
Oh, I bet they have different inhibitors.
You're gonna have to be more specific. Like, what's happening in the hypothalamus and the pituitary?
Okay, yeah, I wrote.
She's an alpha.
I said the TSH, wait, you need to start with the TRH.
Probably.
Say the beginning with the TRH.
Yeah, so I think, yeah, look at your picture you drew. Right,
So we just explained that whole loop.
basically. So what is the hypothalamus doing that's making
Activating.
that happen?
The TRH is activating the TSH, which is being inactivated by the GHIH. And the reason,
That would make no TSH. We're making lots of TSH.
also you wouldn't be having the
Well, go ahead and talk about it. Y'all are almost there.
It's
Let's see what they're doing.
signal?
What are y'all saying?
I said the hypothalamus gets signals to increase TRH to the pituitary
Mhm.
where it increases the THS.
Okay.
And at the same time, the hypothalamus is sending more signals to the, or is sending the PIH to the
There you go.
hypothalamus to decrease the PRL.
Almost perfect. You said one word that I don't think you meant. It's sending the PAH. Where's the PAH going?
The PIH is going to the pituitary.
Right.
Yeah.
I think you said hypothalamus, but I'm pretty sure you meant pituitary.
I think we're overthinking it.
I think you are too.
Yeah, just for me personally, I'm not sure. So when it says that reduced amounts or whatever, producing very little prolactin, is there any PIH being made, or is it just very little PRH? is being
Could be either one, or it could be both.
So then
You could write any of those things and you'd be right.
Does your body automatically just make very little of the prolactin thing?
Yeah, so for example, like, you don't have a baby, you're not making much PRH up until you have a baby,
So
basically.
you have maybe decreased amounts of PRH and increased amounts of PIH.
Right? And then what about the thyroid stuff?
Decreased amounts of GHIH and increased amounts of TRH.
Right.
Okay.
So you're just saying the hypothalamus is making this amount of what you just said, and you have it.
Increase the FSH and the LH.
All right, so what are y'all thinking? So what's the hypothalamus making?
which one are we talking about?
For your thyroid.
Number 3,
Yeah.
Mhm.
It's making the TRH,
right?
so it can make the TSH, so
Uh-huh.
very little of the GHI.
Right? Yes,
And then
definitely.
On this one,
On the prolactin.
the hypothalamus makes the PRH, makes the PRL, but PIH is being made, so it inhibits.
There you go.
It inhibits.
Yeah,
Mhm.
like there's a lot of it.
Yeah, that's exactly what you're saying. That's perfect.
To the pituitary to stimulate all that.
Yeah,
So when that's all, yeah.
Yeah, because if not, you would get all crazy.
Yeah, there's no
We went
stimulus.
from 3 to 5.
Are you talking about taking hormones after hysterectomy? Yeah, so like you can induce, like if you're studying what you want to know, what happens in menopause, like in mice, you give them hysterectomies, and that's like artificial menopause.
There's no more stimulus to the hypothalamus to send more to the
So you
pituitary.
have
to
to,
the pituitary.
you have to take
Yeah, and then it goes straight into the bloodstream is what it is. Your body divides it up and then it goes into the bloodstream and then wherever it needs to go from there.
Well, I guess it's not that there's no stimulus.
No, it's just,
There's no ovaries and uterus to respond to
Yeah.
the LH anymore.
There's a lot of
Yeah.
PIH being made.
so the cycle's kind of broken.
Because that's why you got little.
Do they change the concentration, or is it just like one steady level of estrogen you take, do you
I
think?
think they
do it depending on, they go from body weight,
Yeah.
and then they go from there on according to how, kind of like
react?
yeah, it's kind of like
Probably.
antidepressants.
Yeah, you kind of start low and see if it
Yeah.
works. And
But that's if they take your ovaries and everything, because my mom just has her uterus removed. She still has her ovaries and everything, and she don't have to take any of it.
right. Yeah, because you don't need your uterus for anything but babies, really.
It's called a partial
Make
hysterectomy.
money and sell hours, guys.
But it's nice though, you don't get it.
All right. So you can kind of see basically the hypothalamus, the reason it has all those different releasing and inhibiting hormones is so it can turn on specific hormones in the pituitary. It's not just, hey, pituitary, make all your hormones. It's like, it's much more specific. And yeah, kind of as I mentioned, we're doing the hardest thing in the chapter first. Most of these pathways are a lot simpler where it's like one gland, making one hormone, doing one thing. It's not these like 7 hormones at once kind of business. All right. And one thing to mention, they basically all have negative feedback too, just like you saw with testosterone and estrogen. So the final hormone that's made, like maybe this is thyroid hormone, it goes back and it blocks the production of the releasing hormone in the hypothalamus, and it blocks the release of that hormone from the pituitary. And that's basically true of all of them. And this is a pretty cool diagram because you can look at all of them and see the feedback. So all these purple hormones, they go back and inhibit their specific green hormone. So like thyroid hormone inhibits TRH and it inhibits TSH. The glucocorticoids, which are like the cortisol, they're going to inhibit these two.
So what would the positive feedback loop do?
So there isn't a positive feedback loop involved in any of those.
So on our study guide, we should say it's not involved, because it asks.
No, it says explain.
Where does it say? Oh, just the difference between, where does it say that?
So the positive feedback loop has no effect.
So basically this, positive feedback is as if,
Yeah, going back to homeostasis.
no, it would make this hormone, would tell it to make more,
Like childbirth.
like childbirth, like that one from 201.
Make you contract. Like you're not getting a positive stimulus or anything.
No, but it's just saying produce
making it
more.
work to then get.
Okay.
So just to know what that means,
So it just-
basically everything in this chapter is negative feedback.
Yeah.
It's like way, way more common. Because negative feedback brings you back to homeostasis, which is what you're always trying to do.
Yeah.
All right.
I didn't see it in the book, so.
So posterior, it's a lot simpler. Hormones are made here, and these blue and green lines are actually axons, and the axon terminal is in the posterior pituitary. There's no blood vessels, it's not traveling through the blood, it's just going through an axon, and it's stored down here until it gets a signal to get released. So you'll get the signal up here, and then how do you send signals down an axon? Chapter 12. How does it get from, this would be like the dendritin, this is the axon terminal, how does the signal get there? Starts with an A. So an action potential, remember that word? So you start an action potential here, like, based on whatever the signals are from the hypothalamus, and it travels down here, and then those hormones are released from the terminals straight into the capillaries. And it's got a special name, just like everything. It's called the hypothalamo-hypophyseal tract. Remember a tract is a group of axons? Maybe you don't, it's been a while. All right. And so basically you could see them being produced, and then the green lines are the axons, and then down here in the posterior pituitary, there's a bunch of capillaries. So you just release them into the capillaries, and then it's going to go into the veins to the blood, to everywhere else. All right, what if you compare anterior and posterior? Let me go this way. Oh, that didn't take all one. All right, so looks like you could use some group discussion on this one. This is a hard question. All right, final votes. What you got? All right, so we got 2/3 E. E is not right. The answer is actually D, which I think only one person picked. Right, it's two, yeah. So which other ones did you think, which other ones were you tempted by?
We thought C and D.
It's a good one. So only the ones going to the interior go through a vein. The posterior go through axons. It goes through little tracts. So the ones going to the anterior pituitary, they go into these veins here, or these capillaries, and through the, where's the label? Oh, yeah, the portal veins to here. But the posterior, it just travels straight through these axons to the posterior. All right. And it's extra mean because it's almost always more than one of the above. Right? It's always that, but not this time. All right. You already know about ADH. You're probably sick of it by now. Oxytocin. You've heard of that hormone before, maybe? Right? It's like the bonding hormone. Probably the biggest release is during and after labor, or anytime you're very happy, you're getting like an oxytocin release. And there's a lot of people, some kind of evolutionary people would say like oxytocin is like the bonding hormone. And even, that's the main reason you make it. It's like you make oxytocin, and whoever you're around, when you produce it, you're extra bonded to that person. That's one of the ones released like during an orgasm, for example. So that's like the idea of like why animals have that. So you're bonded to that person. That hormone kind of helps that. Because, other animals make it too, not just us. All right. And time's up. Okay, so we'll just review ADH a little bit next time. But otherwise, that was almost everything except the very last